Hit record on this thing. Trig, I love trig. Find the missing sides. These first 6 problems,
yeah,
we're going to do them a little different.
okay.
Actually not. This is not trig. Yeah, it is trig, but not really. In other words, we don't need trig to do these problems. Here's what we need. We need these 2 triangles. Sorry, let me take a picture here. These 2 triangles, they've been teaching you for years. And what we need is their dimensions. The 3060 has what dimensions? And the other one is the 4545. If we can know these dimensions, then we can answer each of these 6 problems, and that's the way we're supposed to do it. You do have to memorize these, and I can't stress it hard enough. You gotta know what these dimensions are. There is at no point in math where you won't have to know this. These 2 triangles are extremely special. You should know that the side opposite the smallest angle is 1 in both triangles. And then the side opposite the 60-degree angle is √3. That makes the hypotenuse 2. And over here, the hypotenuse is square root of 2. Okay? So these are your 2 reference triangles. You want to memorize everything you see that I've drawn. Everything. You with me?
Yep.
Now, what you're going to do is you're going to compare each of these triangles to whichever is the appropriate triangle. Tell me what why can I not think of the word? What's the linear ratio between those 2 triangles? I'm sorry, I meant the similarity ratio. It's the same as the linear ratio, but it's usually called the similarity ratio. I don't know what your teacher calls it. You get it by dividing the bigger triangles, same side, by the smaller triangles, same side. I've circled both hypotenuses. So what is the similarity ratio? Divide 10 by 2.
Would 10 by √2?
Nope. We're not looking at this triangle over here on the right. This is a 60-30.
Okay.
So we're looking at the triangle on the left.
Oh, okay. Yeah. It would be 5.
Okay. And what that means is that every single side of that triangle is 5 times bigger than every single side of that triangle. It's as simple as that. That's why you always have to get your similarity ratio. And then to get this side here, I'm going to take my similarity ratio and I'm going to multiply it by that 1. So that is side 5. And I'm going to do the same thing for the side opposite the 60-degree angle. I'm going to take the similarity ratio and multiply it by √3, which gives you 5 √3. And we've just solved everything. So all 6 of these problems, that's what we're going to do. Okay?
Okay.
Now, I'm going to leave those 2 triangles up there for a moment, but I'm not going to leave them up there for the whole 6 problems. I want you to memorize them. There's just nothing you can do. You got to memorize these two triangles. That's all there is to it.
Okay.
Problem 2. We're looking at this triangle. What's the similarity ratio?
Divided by root 2.
What divided by root 2? Similarity ratio is called a ratio because it's always two numbers, one on top of the other. In other words, the other one was really 10 divided by 2.
Okay.
This one is 42 divided by square root
2.
You just have to find the similarity ratio by finding the right side. In other words, that is the hypotenuse, okay? So I'm going to compare it to that hypotenuse. You can't compare the hypotenuse to one of the short sides to get your similarity ratio. This is the only way to get it. You got to compare the same sides. Now, I call it a similarity ratio. Notice I did not say that this triangle was 5 times bigger than the smaller one. That's actually not a true statement. It's a lot more than 5 times bigger. If I was comparing areas, the area of this triangle is much more than 5 times bigger than the area of that triangle. Because it's two-dimensional. It's not a linear relationship. The 5 to 1 or 10 to 2 is the similarity ratio, which is a linear measurement, a linear comparison. Okay, now what we do is we take our similarity ratio and we multiply it by that number to get x and by that number to get y. So that's 42 over root 2, and that's 42 over root 2. What's wrong with that answer?
It's not in radical form?
It's not rationalized. In other words, that answer has an irrational denominator. So how do you rationalize it? Here, 42 over root 2. How do you rationalize that?
You multiply both of them by root 2?
Top and bottom. What you're really doing is just multiplying that fraction by the number 1. Notice that root 2 divided by root 2 is the number 1. You can multiply any fraction by the number 1 without changing its value. So we're not changing anything. It's just we get a different answer. We get 42 root 2 over 2, which becomes 21 root 2.
Okay.
So that's what our answer should be, not 42 over root 2, but 21 root 2. Same exact process on every one of these problems. Okay, I'm going to leave them up there for one more problem, and then I'm going to erase them. My two special triangles. You never can memorize anything if you're always looking it up. You have to actively memorize it. So, number 4, which triangle are we talking about?
No, we're on 3.
Excuse me. Number 3, which triangle are we talking about?
30, 60, 90.
What's the similarity ratio?
So 15 root 3 divided by root 3?
No, divided by the same side in that triangle. The side is the side that's opposite the 30-degree angle, right?
Yeah.
So we go to our special triangle, and we look to the side opposite the 30-degree angle, which is 1. So now we're going to divide 15 root 3 by 1. That is the similarity ratio.
Okay.
Now, to get the other two sides, merely take your similarity ratio and multiply it by the other two sides. So what's the hypotenuse?
30 root 3.
And what is the side opposite the 60-degree angle?
It would be, so 15 root 3 divided by root 3.
Not divided, multiplied.
Oh, okay, yeah. And would that be, so
15 root 3 times root 3. What's root 3 times root 3?
3.
3 times 15.
Oh, okay, so it comes, okay, yeah. So then it would be 45.
Okay. Now, the reason you multiply is these triangles they're going to give you are always going to be bigger than the unit triangles. These, incidentally, that I've drawn down here, those are just unit triangles. I could label these anything I want. My pencil just went out. Daggone it. That's bad because I'm probably going to have to reboot my machine. Let's see. Let me see what happens. Wait, unplug that and plug it back in. Maybe. Nope. Daggone it. Let me close it out. And lately, I've been only able to get this to work by rebooting my computer and going that route. Let's see if this will work real quickly. Oh man, that's not a good sign there. Ah, perfect. Worked. Don't have to reboot. Good. Let's see. I do have to go back. This was the page we were on, wasn't it?
Yeah.
This is weird. Okay. I got to download that file. And then, all right. Hold on 1 second. It should be coming up here. Wow. I may have to reboot. This is acting very strange. Okay, I got that far. Expand it a little bit. And scroll down. All right, since I don't have those two triangles on there, I won't put them on there. Okay,
Okay.
let's do 4. What's the similarity ratio?
6 multiplied by root 2.
When you are finding the similarity ratio, what you're basically doing is finding how much bigger this triangle is than the one that is our special triangle. So it's always division, right? If
Okay.
I'm 6 foot tall and you're 12 foot tall, you're twice as tall as me. And you get that by dividing your height by my height. So that's what you're always doing when you get the similarity ratio, is you're dividing the 6 by whatever the hypotenuse of that 45 is. What is it?
Okay. Root 2.
Okay. Now let's go ahead and rationalize that before we go further. There's no reason to put down 2 irrational answers. Might as well rationalize it. What do we get when we rationalize that?
You'd get 3 root 2.
Okay. That's the similarity ratio. That means every side on this triangle right there is 3 root 2 times every side on that unit triangle. Got to get that concept down because you're going to use it over and over and over. Now, to figure out what these sides are, you take that similarity ratio and you multiply it by what the sides were down here.
Okay.
So what are my two sides?
So it'd be 3 root 2 multiplied by root 2.
Nope.
And
Oh, nope, nope, nope. Hold on. Let me label this triangle down here. That is 1, 1, root 2. Okay?
oh,
You got
okay.
your
Yeah.
similarity ratio by comparing that 6 to that root 2 because they're both the hypotenuses. Now, once we see that this triangle is 3 root 2 times bigger than this triangle, every side has to be 3 root 2 times bigger. So I make 3 root 2 times 1. That gives me 3 root 2 there and 3 root 2 there. On a 45-45, these sides are always the same. So once you figure out one, you know the other. Okay?
Yeah.
Go on. Number 5. It's the similarity ratio. Always the first step. Step's always division. Second step's always multiplication.
So it's
That's the 60-degree angle there. Tell me what the dimensions are on this 30, 60, 90 special triangle.
1, 2, and root 3.
Yeah. The 1 and the root 3 are opposite the two angles. So what's the similarity ratio?
9 divided by root
Okay.
3.
I can see you struggling, and you don't need to be struggling. The 9 is opposite the 60-degree angle.
Yeah.
So all you do is find the side that's opposite the 60-degree angle.
So 9 root 3.
9 divided by root 3.
Yeah.
Not 9 root 3. That's a different answer. Okay? Now you got to rationalize that. So rationalize that.
So multiply by root 3. And
You're multiplying by root 3 divided by root 3.
yeah. Root 3.
Yeah. Okay, so now we have our similarity ratio. It means every side of this triangle is this much bigger than every side of this triangle over here, the unit one. So let's figure out, here, let me erase some of this so we can label that triangle. What is the hypotenuse? Start there.
3 root 3 divided by root 3.
You're not dividing anymore. First step is division. Second step is multiplication. Every time. The division is where you figure out the similarity ratio. Once you figure out the similarity ratio, okay, you're 12 foot tall, I'm 6 foot tall. That's a 2-to-1 ratio. If my hand is 12 inches wide, how do you get your hand? By multiplying, right?
Yeah.
Okay. Exactly the same. In other words, you get the similarity ratio by dividing your height by my height to get 2-to-1. And then you get the length of your foot by multiplying by the length of my foot by 2-to-1. So it's always a division to get the similarity ratio and then a multiplication to get the other sides. So let's start with the easy one, the hypotenuse.
So 3 root 3 multiplied by root 3
Not root
is
3. Hold on. That's not the same side. We're talking about the hypotenuse. That's the hypotenuse. We're going to solve each side, but one step at a time. Let's do the hypotenuse first. So it's the similarity ratio times that hypotenuse from the unit triangle. So this hypotenuse has to be 6 root 3, which is exactly which is exactly 3 root 3 times 2. Now tell me what the side opposite the 30-degree angle should be.
It'd just be. Would you do? It'd be 3 root 3.
Yes, exactly. In other words, you take your similarity ratio and you multiply it by that 1, because that 1 is the side that's opposite the 30-degree angle. Okay, let's do 6. Another 30, 60. What's the similarity ratio?
It is 12 divided by 2.
Nope, you got to divide it by the same side. You're not dividing by the hypotenuse.
Oh, okay. So 12.
This 12 is not the hypotenuse. That 12 is the side opposite the 60-degree angle. So you
So
have
is that how
to
you?
divide by the side that's opposite the 60-degree angle.
So for similar ratio,
Similarity ratio.
yeah, you always do. So for this case, you do 12 by whatever side it's on.
You're comparing same sides.
Okay.
Here, I'm going to draw it one more time.
So in this
There's
case, it
the
would be
30. There's the 60. Opposite the 30 is always 1. Opposite the 60 is square root of 3. The hypotenuse is 2. Okay?
okay.
So in this case, the only thing they've given us is the side opposite the 60.
Okay.
So what's the similarity ratio going to be?
12 divided by root 3.
Yeah, it's that simple. You just have to compare same sides. In other words, remember corresponding parts of corresponding triangles are corresponding, or whatever CPCTC was? Well, that's what we're doing. We're comparing corresponding sides. You always, whenever you do this division, you only want to divide the side that is opposite the same angles. In other words, I want to divide the side opposite the 60 by the side opposite the 60 in my unit triangle. Now rationalize that.
Okay. It would be 4 root 3.
Now tell me what the side opposite the 30-degree angle should be.
Wait, would that reduce again to 2 root 3?
Nope. That 4 is not in, that 4 is not inside the radical sign.
Okay. So then, wait, what side did you want me to find?
Opposite the 30
It would be 4 root 3.
and opposite, what's the hypotenuse?
It would be 8 root 3.
Okay, I think you got it now. Every time you see a 30-60 right triangle or a 45-45 right triangle, this is what you want to do. You don't want to use trig. For one thing, they're not going to give you enough information to use trig. couldn't really use trig to figure out. I guess we could. I guess we could take the sine. Yeah, you could take the sine of 60 degrees equals this side over 10. But I'm quite certain that they don't want you to use trig here. They want you to use these similar triangles. I might be wrong. They might not mind you using trig on this. But regardless, you want to be able to use similar triangles. You want to always be able to compare similar triangles. Okay. Let's just do one of these because you can't do them. I got to do them. So 158 degrees. Where does that ray, which quadrant is it going to go in?
Quadrant 2.
Okay, it's going to be about that. And there's your 158. Okay. About minus 245. How am I going to draw that?
You're gonna go the opposite way.
Correct. So I'm going to go this way for 245. Well, that's 180. So where am I going to end up? Which quadrant?
Quadrant 2.
Also. So if I went 180, I got to go another 65. So we'll call that minus 245. Okay, how about 505?
So you'd end up in quadrant 2.
Correct. In other words, 505 goes all the way around once. That's 360. And I got another 145 to go, which puts it right there. Okay. Radians. How comfortable are you with radians?
Kind of comfortable.
You can always do one thing. Until you get truly comfortable with them, you can always convert them to degrees and just sketch it just like we did. How do I convert radians to degrees? What do I multiply by? What's the conversion factor?
Is it pi over 180?
It's either pi over 180 or 180 over pi. Which is it?
Okay.
Which is it? Because it's different depending on whether you're going from degrees to radians or radians to degrees.
Oh, it's 180 over pi.
Correct. Let's go up here and look at it. It's got to be pi over 180 if I'm converting this 158 to radians, because I want to lose my degree units and I want to pick up radians, and the radians go with the pi.
Yeah.
So this has got to be the opposite. This has got to be 180 over pi. And 15 goes into 180 12 times. 12 times 7 is 84. Here's your answer. 84 degrees. And that makes sense because we know pi over 2 is 90 degrees. And so 84 degrees, that's slightly less than pi over 2. And let's label it in radians. So that's kind of the hard way to do it. And I'll explain why in a second. If I do this one, rather than converting it, they just say sketch the angle. That means we don't have to be very exact, right? What is this slightly less than?
1
pi.
Oh.
9 pi over 9 would be pi. This is 8/9 pi. Okay? If I'm going a negative angle, well, that's negative pi.
Yeah.
So negative 8/9 pi must be just a fraction. This one right here. That is minus 8 pi over 9. Or close enough. And close enough's got to be correct in this case. Otherwise, they'd say use your protractor to draw it. Okay? So
Okay.
I don't really need to convert that to degrees. I didn't really need to convert that to degrees. As long as I knew that pi over 2 was 90 degrees. Now I want to teach you something about these radians that I find extremely helpful. What do you notice about each of these?
They're all factors of 15.
No. These are true. Pi over 2 is 90 degrees, pi over 3 is 60, pi over 4 is 45, pi over 6 is 30. And the way you memorize these is those two numbers always multiply to 180. Notice 3 times 60 is 180, 4 times 45 is 180, 6 times 30 is 180. So it gives you an extremely convenient way to memorize the basic first quadrant angles, the ones that they care so much about, which are 30, 45, 60, and 90. And if you can do it this way and bypass this conversion factor, you'll find it's a lot easier. For example, if pi over 3 is 60, what's 2 pi over 3?
120?
What's 4 pi over 3?
240?
Isn't that a lot easier?
Yeah.
Okay. It works, but you've got to be good with the number 180. In other words, what's pi over 12 equal to? Pi over 6 is 30. Pi over 12 is half that much. So
15.
okay, and notice 15 times 12 is 180.
Yep.
So what is 7 pi over 12? 7 times 15, right?
Yeah.
To me, this is by far the easiest way to convert radians to degrees. Going back the other way, not so usable. In other words, when you're going from degrees to radians, which we didn't have to do in 7, 8, or 9, but if we did have to do it, then you pretty much have to just multiply by that conversion ratio.
Yep.
But when you're going from radians to degrees, and again, we didn't have to do it to graph it. What we did need to know is that pi over 2 is a 90-degree angle, and that's just slightly less than pi over 2. But learn these 4 right here. And they're nothing to learn. Just always know that if you have pi alone in the numerator, not 2 pi or 4 pi or 3 pi, but pi alone, then its denominator multiplies by the answer to give you 180, always. And even though these are only certain types of angles, in other words, I can't tell you what pi over 7 is, because 7 doesn't multiply by any number to give you 180. So that's a weird one. That's a fractional degree one. But that's not the kind of angles you deal with when you deal with trig. You deal with pi over 2, pi over 3, pi over 4, and pi over 6. These are the angles you always are dealing with. despite this problem here. But this problem is not convert, this problem is sketch. All right. So we've sketched 10, 11, and 12. Let's scroll down. Okay, now we're going to convert. Let's do the easy ones first, using the technique I just taught you. Wow, I wasn't even looking at this problem either. What's 7 pi over 15 in terms of degrees?
So it'd be
Figure out what pi over 15 is. Take your calculator and divide 180 by 15.
12.
Okay, so pi over 15 is 12 degrees. Because 12 times 15 is 180. So what's 7 pi over 15?
So 7 multiplied by 12?
84 degrees. Okay.
Yep.
Pi over 9 is what?
It is 20.
So what's 8 pi over
9? 160.
And it's still negative. Negative 160. Okay. Yeah, this is so much easier to use this method because otherwise I got to multiply that by 180 over pi and then I got to do all the arithmetic. I don't know. It's the same thing. In essence, it's just a little bit of a shortcut. All right, let's scroll down more.
Wait, so how do we do it the opposite way for 13?
You're right. Sorry. Yeah. That you have to use the conversion factor.
So how would you, is that?
You got to know that conversion factor. It's either pi over 180 or it's 180 over pi.
It's pi over 180.
Now do the math.
So like, how do you do that though? Like, are you just supposed to?
Well, here's what you have to convert, okay? We're going to have pi in our answer, but you have to simplify that. Well, the zeros cross out. I can cut that in half, that in half. There you go, 10/9 pi.
And it's the pi, okay, yeah.
Yeah, the pi didn't go anywhere. I'm just bringing it forth. The only thing I had to handle was that fraction. And I don't want a decimal answer. I do not want a 1.0999 pi, which would be our decimal answer. Okay? You would lose points for that. This is the answer he wants. But the only way to get that answer is to reduce that fraction manually. Can't really do it with a calculator. Not unless you have one of those calculators that takes your decimal answer and converts it to a fractional answer for you. Do you have one? And do you know how to do it?
To do what?
Take a decimal answer and convert it to a fractional answer.
No, I did not know how to do that.
In other words, if you put this into your calculator, what kind of calculator do you have?
TI-84.
There is a key on there that will turn that 0.125 into 1/8. See if I can find it. I've got a TI-85, it's just not working. So it's all I can see is the keyboard. I don't remember which key it is, but it's extremely valuable to remember, because otherwise you got to do this problem by hand.
Yeah.
Notice that if you put in 20 or 200 divided by 180, it's giving you that fraction. It's actually, I think 1.11 is 1/9. Yeah, 1/9 is 1.111. Okay. But you don't want a decimal. You might not lose credit if you put a line over that one like that to indicate that it repeats forever. But the real way to do it is that's what you want as your answer. Whenever you're dealing with radians, you want fractions, not decimals. Okay?
Okay.
All right, let's do 18. Multiply by what?
Okay, yeah. So how?
What's the conversion factor? You can always resort to the conversion factor. Always. Regardless of whether you're going radians to degrees or degrees to radians. Just make sure you put your conversion factor where the units cancel.
So we're doing pi over 180 again?
Uh-huh. It's always pi over 180. If you're going from degrees to radians, it's always pi over 180. Because the 180 has the degrees on it. And we want to lose the degrees. Those are going to cancel. And the pi has the radians on it, even though we rarely write radians. And that's a more complicated thing to explain why they don't come with radians on there, but they don't. Okay, so now you have this that has to be reduced. How do I simplify that? What number do I know divides into both top and bottom?
5.
Okay, do it. Tell me what you get. You can use your calculator to divide the top by 5 and the bottom by 5.
It equals 67 over 36.
Yeah, and notice that 67 is prime, so I'm not reducing it any further. 67 is not divisible by anything but 67 and 1. So that's my answer.
But it says find the points.
Ah, you're right. You're right. Sorry, I was still doing this, which was convert. Yeah,
Okay.
this is a little different, isn't it? My apologies. So this one ended up being 9/8 pi, right?
Yeah.
Okay. Find the coordinates of point P on the unit circle. All right. Here's the thing. If I have an angle, no matter what it is, the coordinates on the unit circle, the first coordinate right there, that's the cosine of that angle. The second coordinate, the y-coordinate, is the sine of that angle. This is extremely important also. Okay? So we know the angle. Put your calculator in, I don't know, either degrees or radians. Yeah, we didn't actually need to convert that to radians. I apologize. I misread the direction. Let's just do that and apply cosine of theta. In other words, take the cosine of 200. What's that?
It is 0.48.
Don't think so. Cosine of 200 degrees. You're probably in radians.
Oh, yeah. It's negative 0.94.
Okay. So the x-coordinate is negative 0.94. Now take the sine at 200 degrees. That's going to be the y-coordinate.
And that's negative 0.34.
Okay, so if I'm drawing this on the unit circle, then my x-coordinate is right about there. My y-coordinate is right there. So that has minus 0.94, comma, minus 0.34. Those are my x and y coordinates. I'll draw my ray, and there's my 200 degree angle. Okay? What you have to remember is this right there. That's not that obvious. It's something you got to memorize. That whenever you're on the unit circle, the point, wherever it is, that point right there, its x-coordinate is the cosine of that angle, and its y-coordinate is the sine of that angle. Everywhere on the unit circle. Okay? So,
Okay.
let's do 18. What's the x-coordinate going to be?
It's going to be 0.906.
And that's fourth quadrant. Cosine should be positive, so that's correct.
How do you know that's in like the fourth quadrant, man?
Because the unit circle is 360 degrees.
Oh, okay, yeah.
90 degrees to there. It's 180 degrees to there. It's 270. So anything between 270 and 360 is in the fourth quadrant.
Yeah.
Okay, what's the y-coordinate?
Sine. Negative 0.422.
That also is correct because sine is supposed to be negative in the fourth quadrant. As far as that angle goes, well, I know that it's 25 degrees short of a full circle. So the angle, there's your 335 degree angle. And the coordinates of that point, there's my unit circle, so they want the coordinates of that point right there. That's the x-coordinate, that's the y-coordinate. Okay? One last, 19. Again, I can draw easy enough because I know that's 90 degrees and that's 180 degrees. So it's got to be about there. Okay, now I put my unit circle around it. What are the coordinates of that point right there?
Negative 0.54.
That's correct because I'm on the left side of the y-axis, so my x-coordinate should be negative. It's my y-coordinate.
0.84.
And my y-coordinate should be positive because I'm above the x-axis. And so that's correct. And that's a reasonable drawing of it. I'd label this point, but God, they give us such weird numbers here. Not weird, but long. All right, Lachlan, we've got 5 minutes. Shall we look at another diagram?
I think that's everything.
Oh, okay. Better yet. We covered it all. So, sounds good. I will talk to you next time.
All right, thank you.
You're welcome.